Welcome to the AI Safety Podcast, where we introduce you the latest research.
Welcome back, everyone, to the AI Safety Podcast. We're diving into some really fascinating stuff today.
Yeah.
From a paper by OpenAI
Okay.
called Diverse and Effective Red Teaming with Auto-Generated Rewards and Multi-Step Reinforcement Learning.
Mm-hmm.
It's a pretty dense title.
Yeah.
But basically, they're using AI to attack other AIs to find vulnerabilities.
Right. So, like, we're training these AI red teamers to think like attackers.
Exactly.
And they're specifically looking at how to exploit attention mechanisms and reward functions in these systems, which is...
Oh, yeah, attention mechanisms. That's something we haven't really gotten into too much on the show before.
Right. It's such a crucial part of how a lot of these AI systems work.
Yeah. Can you maybe give us like a quick refresher on what attention is in this context?
Sure. So think of it like a spotlight that the AI uses to focus on the most important parts of the information it's looking at.
Okay.
Like if it's reading a news article, the attention mechanism helps it figure out which words and phrases are really key to understanding the whole thing.
So it's like it's filtering out the noise and zeroing in on what matters.
Yeah, exactly.
But I'm still not quite seeing how that becomes vulnerability.
But the problem is that you can manipulate that spotlight.
Oh,
You can trick the AI into focusing on the wrong things.
I see.
Like imagine you've got an AI that's supposed to summarize financial reports. An attacker could sneak in some subtle changes to the data
Okay.
and shift the AI's attention away from the important stuff.
So it ends up with a totally misleading summary.
Exactly.
And this paper is all about how to do that kind of manipulation.
Right. And they get pretty deep into the weeds.
Oh, yeah.
Even looking at the math behind how these manipulations affect the attention weights.
Okay, now you're talking my language.
So we're getting into the nitty-gritty of how much focus the AI gives to different pieces of information.
Right, those attention weights.
Exactly.
So how does that actually work, like mathematically?
Well, you can think of it like each word or phrase in the input data has a corresponding attention weight. And those weights are calculated by some pretty complex math inside the AI system.
I can imagine.
Lots of matrix multiplications and stuff like that.
Yeah.
And the attacker's goal is to mess with those weights.
To make the AI pay attention to the wrong things.
Precisely.
Wow, that's pretty wild.
Yeah, and there are different ways to do it. Like, you could subtly change the numerical representations of the words.
Those word embeddings, right?
Yeah, those embeddings capture the meaning of the words in a mathematical way.
Right, like vectors in a high-dimensional space.
Exactly. And by tweaking those vectors, you can change how the AI sees the relationships between words.
So it's like they're hacking the language itself.
In a sense, yeah.
That's a bit scary.
It is, because it shows how even these really sophisticated AI systems are still ultimately based on math.
Right, and that math can be manipulated.
Exactly.
Okay, let's switch gears a bit and talk about reward functions.
Sure.
We know those are another big target for these attacks.
Definitely.
Could you remind us how reward functions work?
It's like the AI's internal compass. It guides the learning process.
Okay.
It tells the AI what it should be doing and what it should avoid.
Like a dog getting treats for good behavior.
Yeah, exactly.
But obviously it's not actually treats for AI.
No, it's all about mathematical calculations again.
Of course.
The reward function assigns a numerical value to each action the AI takes.
And the AI tries to maximize that reward.
Right. So if we're talking about hacking the reward function, it's all about messing with that calculation.
Finding ways to trick the AI into thinking it's doing the right thing when it's actually doing something bad.
Exactly.
Wow, this is getting pretty complex.
It is, but that's what makes it so interesting.
So what are some of the techniques they use to actually pull off these attacks?
Well, one of the key things is this idea of multi-step reinforcement learning.
Multi-step. Okay, that sounds intense.
It is, but maybe we should take a little break here and come back to that in the next part.
Sounds good to me.
So multi-step reinforcement learning.
Yeah, that's where we left off.
It's kind of like, imagine training a dog to do a really complicated trick.
Okay.
But instead of treats and commands,
Yeah,
you're using algorithms and data.
right. So these red team AIs aren't just trying one attack. They're learning a whole sequence of moves.
Exactly. It's not like just one sit or stay.
Yeah.
They're figuring out a whole routine.
So it's more like a skilled hacker.
Yeah. Probing a system, trying different things, seeing what works.
Learning from each attempt.
Exactly. And that's what makes this multi-step approach so powerful.
I can see that it allows for much more sophisticated attacks.
Definitely. And the way they set up the rewards is really interesting, too.
Oh, yeah. How so?
Well, in a typical reinforcement learning setup, the AI just gets a reward at the very end.
Right. Like it either succeeds or fails.
Exactly. But here they're giving the AI intermediate rewards along the way.
Interesting. So it's not just about the final outcome.
Right. It's also about how you get there.
Like bonus points for style and creativity.
Exactly. They want the AI to find clever and efficient ways to attack.
Do they give any specific examples of these intermediate rewards?
Yeah, like one example is they reward the red teamer for finding shorter attack sequences.
Oh, that makes sense. So it's not just about finding any vulnerability. It's
Right.
about finding the most exploitable ones.
The ones that a real attacker would actually use.
Yeah, because in the real world, you don't want to be messing around with something that takes forever.
Exactly. You want the most efficient attack.
Right.
So they're really pushing the AI to optimize its strategy.
I'm still trying to wrap my head around how they're actually manipulating these reward functions.
Yeah, it's pretty subtle.
It seems like a really delicate process.
Think of it like
Okay.
you're trying to train a dog to fetch a particular toy, but instead of showing it the toy directly, you're just giving it little clues.
Oh, I see.
Like rewarding it for moving in the right direction, even if it doesn't get the toy on the first try.
So you're guiding it towards the goal.
Exactly. And that's kind of what they're doing here.
Instead of changing the reward function's code directly.
Right. They're manipulating the information the AI receives.
So they're shaping its perception of the world.
Exactly.
Like they're training the AI to see the vulnerabilities and ignore the safeguards.
Yeah, that's a good way to put it.
Did they mention any specific vulnerabilities that were particularly easy to exploit with this method?
They specifically talked about jailbreaking and indirect prompt injection.
Ooh, sound familiar.
Yeah, we've touched on them before.
But can you remind me what they mean in this context?
Sure. So jailbreaking is like you've got a chat bot that's supposed to be harmless,
Okay.
and you trick it into generating harmful content.
So you're bypassing its safety protocols.
Exactly.
And what about indirect prompt injection?
That one's even trickier.
Oh, yeah.
It's about exploiting the fact that a lot of these AI systems rely on external information.
Right, like they pull data from websites or other tools.
Exactly. So imagine you've got an AI that's designed to summarize news articles.
Okay.
An attacker could manipulate the content on those websites.
Why is he?
So the AI ends up producing a biased summary without even realizing it's been tricked.
So it's like poisoning the well.
Yeah, contaminating the source itself.
Yeah, it's pretty insidious.
It is, and it shows how these attacks are getting harder and harder to detect.
As AI systems become more complex and integrated into our lives.
Right. The potential attack surface just keeps expanding.
So we're not just talking about vulnerabilities in the code anymore.
Right. It's about the data, the interactions, the whole environment.
It's a whole new level of security challenges.
It is, and that's why this research is so important.
Yeah, we need to be aware of these threats.
Exactly.
But are these just theoretical threats, or have there been real-world examples of these attacks happening?
Well, the paper itself focuses on controlled experiments.
Okay.
They're testing these attacks in simulated environments,
Right.
but they make it clear that these vulnerabilities are real.
And they could have serious consequences.
Definitely. They even found some previously unknown vulnerabilities.
Wow, so this red teaming approach is really effective.
It is.
But the goal here isn't to scare people, right?
No, of course not.
It's about understanding these risks so we can mitigate them.
Exactly. We need to be proactive, not reactive.
So how do we do that? How do we build AI systems that are more resilient to these kinds of attacks?
One key area is anomaly detection.
Anomaly detection. Okay.
We need to teach AI systems to recognize when they're being manipulated.
So they can raise a red flag.
Exactly.
But how do you teach an AI to be suspicious, to question its own reality?
That's a great question, and it's a really active area of research.
I bet.
One approach is to expose the AI to lots of different adversarial examples.
Like training data that's specifically designed to trick it.
Exactly, so it learns to recognize the patterns of deception.
So it's like giving the AI a digital immune system.
Yeah, that's a good analogy.
So it can defend itself against a whole range of attacks.
Precisely.
This has been a fascinating look into the world of AI red teaming
It has.
and the challenges of securing these increasingly complex systems. But before we wrap up, I want to zoom out a bit
Okay.
and talk about the bigger picture.
Yeah.
What are the implications of this research for the future of AI?
That's a big question.
It is, but I think it's an important one.
Yeah, for sure.
Yeah.
Yeah, it's like we're just at the beginning of this whole AI thing.
Right. It feels like we're constantly playing catch up.
Totally. And it's not just about the technology itself.
What do you mean?
Well, we need to be thinking about the ethical implications, too.
Right. The societal impact.
Exactly. Like, what values are we building into these systems?
That's a huge question.
It is, and there's no easy answer.
And how do we ensure that AI is used for good?
That's another big one.
It feels like we're opening up a Pandora's box.
In a way, yeah.
But this research is helping us understand those risks.
Absolutely. It's giving us the tools to make more informed decisions.
So it's not just about pointing out the problem.
Right. It's about finding solutions.
And that's where this whole idea of AI safety comes in.
Exactly. It's about making sure that AI is aligned with human values.
Which is a lot harder than it sounds.
It is, but it's essential.
Because the potential consequences are huge.
They were both positive and negative.
Right. AI could solve some of our biggest problems.
But it could also create new ones.
So we need to be really careful.
We need to proceed with caution, but also with a sense of optimism.
Yeah, I like that balance.
Because AI has the potential to make the world a much better place.
If we do it right.
Exactly.
This has been a really thought-provoking conversation.
It has been.
I always learn so much from talking to you.
Well, I appreciate that.
I think our listeners will get a lot out of this episode, too.
I hope so.
Thanks for joining us, everyone.
Of course, it's been a pleasure.
And we'll be back next week with another deep dive into the world of AI safety.